You ever wonder what really happens when you click a link or tap on an app? I mean, underneath it all, there's this hidden architecture, this invisible set of rules that makes our entire digital world work. Today, we're going to pull back the curtain on the internet's original blueprint, and you'll see why this decades-old model is actually more important than ever for the tech we use every single day. All right, let's start with a question that drives us all crazy, right? From the average user to the most seasoned IT professional, we've all screamed this at our screens. Why is my application so slow? It sounds like a simple question, but the answer, well, it's usually buried under so many layers of complexity. Is it the network, the server, the code itself? Seriously, where do you even begin to look? And part of the reason that question is so tough is because a single app today isn't just one thing anymore. It's this sprawling, complex ecosystem. You've got little microservices running in these self-contained packages called containers. And those containers are scattered everywhere, across different cloud services, on virtual machines, maybe even connecting back to a server sitting in an office closet. It's a beautiful, organized chaos.
So how in the world do you navigate that chaos? When something breaks, how do you find your way? Well, you need a map. And it turns out the best map we've ever had for this stuff is a framework that was designed decades ago. It's a model specifically for bringing order to the crazy complexity of network communication.
And here it is. It's called the OSI Model. Now, this isn't a piece of software you install or a physical device. Think of it more like a universal blueprint. It's a way of thinking that breaks down the massive, overwhelming job of network communication into 7 distinct, manageable layers. It's the standard that helps your phone talk to a data center halfway across the world. The absolute genius of this model is how it organizes everything. It starts at the very bottom, layer 1, the physical layer. We're talking about the actual stuff, the cables, the radio waves, and it builds all the way up to layer 7, the application layer, which is the part we actually see and touch, like our web browser. Each layer in between has a very specific job to do. And here's the key. It only talks to the layer directly above and below it. It's like a perfect assembly line for your data. Okay, but let's be real for a second. This model is from the 1980s. So the huge question is, in our modern world of cloud computing, containers, and AI, do these old rules still apply to this very, very new game we're playing? The answer is a resounding yes. And a Reddit user named level_dog_4257 just put it perfectly. Think about it. The cars driving on our roads have totally changed, right? We've gone from gas guzzlers to hybrids to fully electric, self-driving machines. But the roads themselves, the fundamental infrastructure, it's still absolutely essential. The OSI model, that's the road system for all our data.
And this is the most important thing to get. Nobody today is building technology to be strictly 100% OSI compliant. That's not the point anymore. Instead, its real power is that it's become this essential mental framework for troubleshooting. It gives engineers a logical, step-by-step way to think about and diagnose problems.
So let's see how this framework actually gets put to work today. We're going to look at 2 really critical modern challenges. First, how do we see what's actually happening across all these layers? And second, how do we secure them?
Okay, our first use case is a concept called observability. It sounds like a fancy buzzword, I know, but in our super complex cloud world, it's just the art of understanding what's happening inside your application by looking at the data it puts out. It's all about making the invisible visible.
And observability really stands on what people call the 3 pillars. First, you have metrics. These are just numbers, like how much CPU is being used or how long a web page takes to load. Then you have logs, which are like a super detailed diary of every single thing that happens. And finally, you have traces, which are amazing. They follow one single request, like you clicking buy now, as it travels all the way through that complex system we talked about. Now, this is where the old model meets some seriously cutting-edge technology. Modern tools use something called eBPF. Think of eBPF agents as tiny, super-efficient probes that can safely go right into the core of the operating system. They can tap into each of the OSI layers and collect all those metrics, logs, and traces we just talked about. It's like having a high-powered microscope to see exactly what's going on with your data at every step. All right, the second huge application is, of course, cybersecurity. For anyone whose job it is to defend a network, the OSI model isn't just some abstract concept, it's a battleground map. It helps them figure out exactly where an attack is coming from and how to build the right defenses. Because threats don't just happen in one place.
Attackers target specific layers. An attack might happen down at the data link layer to fool your network about who's who, or at the network layer to fake an address. They can scan for open doors at the transport layer, or even hijack your entire connection at the session layer. And of course, the viruses and Trojans we all know about usually hit us at the application layer. This is exactly why you always hear about defense in depth. You need security at every single layer of the system. So after all that, what's the one big thing you should walk away with? It's a really simple but incredibly powerful idea. Learn to think in layers. The real, timeless magic of the OSI model is that it takes a problem that seems completely overwhelming, like the internet is slow, and it breaks it down into small, separate, manageable pieces. It literally turns chaos into a checklist. And that gives you a disciplined way to solve almost anything. First, you isolate the problem. Is it a bad cable at layer 1, a routing mess up at layer 3, or is it a software bug at layer 7? Once you know where the problem is, you can focus all your energy on a targeted solution for that one layer. It really is a problem-solving superpower. So we've seen how this incredible model maps out everything from physical wires to the software on our screens. But as technology gets woven even deeper into our lives, into everything we do, it really makes you wonder, doesn't it? What's next? What is Layer 8?